Hello viewers, I'm Kausalya. Today we are going to discuss problem 5 and 6 in nodal analysis. So here the problem is determine the voltages at each node for the circuit shown in figure. So this is your given circuit diagram, right? And this circuit diagram, you see it has three different nodes, right? So the main aim of us is to find the voltages at each node here, right? So from the circuit diagram, you see how many sources are there. We are having one voltage source and a one current source, right? And that too, this voltage source is in series with the resistor, right? So therefore, our first step is we are converting a voltage source into equivalent current source, which makes our calculation pretty easier, right? So the first thing is we are converting this 10 voltage source in series with 10 ohm resistor to a equivalent current source. So how to calculate current? The formula for current is as usual by using Ohm's law. Right. So that is V is equal to I into R. So I is equal to V by R. Here the V is 10 and R is 10. So what about I? It is 1 amps. Right. So here you see it is converted into an equivalent 1 amp source and the series resistor here comes in parallel. Right. And the rest of the diagram remains the same. Now the next step is we have to frame the matrix. So since we are having, you see, we are having three nodes and here let be node number 4 which is a reference node, right? So for framing matrices, we have to consider only these three nodes. So we have to frame a 3 by 3 matrix. So just look at node 1. So as usual, I hope you people are familiar in framing this kind of matrices. So 1, 2, 3 and here also 1, 2, 3. And this diagonal elements are nothing but the resistors which are connected to that particular node. Right. That is 1, 1, 2, 2 and 3, 3. These diagonal elements are simply representing the resistors that are connected to the nodes. So here just look at node 1. So when you look at node 1, okay, right, what are all the resistors that are connected to node 1? This 10, this 5, this 3 and this 3. So you have to take the reciprocal and you have to add. So you see 1 by 10, 1 by 5 plus 1 by 3 plus 1 by 3. Again now look at node 2, right? How many resistors are connected to node 2? 1, 2 and 3. So therefore here you have to write 1 by 3 plus 1 by 3 plus 1 by 2. And the next thing is look at node 3. So how many resistors are connected here? Here totally 3 resistors are connected. So 1 by 2 plus 1 by 1 plus 1 by 6. Right. Now just check whether any resistors are common between your node 1 and node 2. So here we are having two 3 ohm resistors. Therefore minus of 1 by 3 plus 1 by 3. And check whether any resistor is common between your node 1 and node 3. So there is no common resistor. Therefore here it is represented as 0. Right. Once you fill the first row, here the same element will occupy these two places. Right. Because here this is the element which is common between node 1 and node 2. Similarly here element which is common between node 2 and node 1. Both means the same. Right. So, and the next thing is between 2 and 3 I am having a 2 ohm resistor here, right? Therefore, minus 1 by 2, minus 1 by 2, you have to always include a minus for the common resistors, right? And the next thing is V1, V2 and V3. So, which is equal to, now to the node 1, what is the current source here we are having? We are having 10 amps, that too it is towards the node 1. Therefore, 1 amps towards the node 1. So here it is 1. And for node 2 we are having 5 amps towards it. Therefore here it is 5. And to the node 3 there is no current source. Therefore here it is written as 0. Right. Once you solve this matrices, you see here we are having a matrix like this. Right. So in this problem we are asked to calculate V1, V2 and V3. So what is the formula to calculate V1? It is del 1 by del. So what is meant by del here? When you take determinant of this matrix, that value is known as del. So here the determinant of the matrix is taken and the value of del is calculated, right? How to calculate del 1? To find del 1, we have to replace this first column by this elements, right? That is known as del 1. So just replace the values and finally calculate. So here the value of del 1 is 7.24, right? So the value of V1 is del 1 by del, so that gives a value of 8.07 volts. Similarly, how to calculate del 2? You have to replace this second column by the respective current sources, right? So similarly, calculate the value of del 2 here. I know you people know the basic step of solving a determinant, right? You see, you have to take this element and you have to multiply these two minus these two. Similarly, when you consider this, here you have to include a minus sign. So minus 1, again you have to leave this row and this column and this row. So you have to multiply these two minus of these two, right? Once you simplify, here we are getting the value of del 2 as 9.161. So here the value of V2 is del 2 by del. So that gives the answer of 10.2 volts here. Again, when you proceed to del 3, you have to replace this third column by the respective current sources. And the value of del 3 is 2.7495. And again V3 is del 3 by del. So that gives the value of 3.065 volts. Right. So here comes the end of our fifth problem. We will proceed with our sixth problem. So here our problem is determine the voltage ratio V out by V in for the circuit shown in figure by using nodal analysis. Right. So you see, so this is the given circuit diagram. They are asked to find a ratio of V out. Okay, this is your V out by V in, output voltage by input voltage. Right. So from this circuit diagram, can you tell me how many nodes are present here? Here only one node is present. Why? What is the reason why we are saying here there is only one node is present here? Because you see these two elements are in series, right? We can combine these two elements and we can represent it as a single resistor. Yes or no? Yes. So that is the reason here the circuit has only one main node and another one is the reference node, right? So we are considering our node A, right? And we are assuming the current flows towards node A. That is, current from 3 ohms flows like this, and here it flows like this, and here it flows like this, right? Therefore, I10 plus I3 plus, we are combining these two resistors. So 6 plus 5 is 11. So I11 is equal to 0. Because all the currents are assumed to be flowing towards the node. There is no current which flows away from the node. So here KCL is applied, right? Now we are writing I10. So how to write the current, value of current that flows through I10? Here we are having V in, okay? Here the voltage value is supposed to be V in here. So how to write expression? So here it is written as VA minus V in divided by 10. That is, I is nothing but V by R, right? So here we are having two different values of voltages. One is VA and another one is V in. Therefore, while writing here, it is VA minus V in divided by 10, right? And the next thing is I3. So here it is simply connected to node A, therefore VA by 3. And the next thing is I11. So current flowing through this I11 also, here we are having only one node, therefore VA by 11, right? In other words, we can simply write it as, this is your output voltage, right? Even V out by 6 also will give you some value of current, right? So we can write it as VA by 11 or V out by 6. So again substituting these values in this expression. So when you substitute it, you see we are taking VA commonly outside. And once you solve, you see here the value is VA by, that is, you see we are taking this expression, right? So VA by 11 is equal to V out by 6. Both means the same. right? Because Va by 11 gives you a current, right? Similarly, V out by 6 also will gives you a current, and these two elements are in series. Therefore, we are holding this expression. So when you solve this expression, Va is given as V out into 1.83, right? Now in the place of Va, just substitute this value. Here we are having Va, right? So just substitute this value here. So once you substitute and solve, you see finally we are ending up with a V out by Vn, which is equal to 0.1042, right? So here comes the end of this problem, even this video. If you have any doubt, let me know in the comment section. Thank you.